Hello friends, welcome to Eastern Academy. We are discussing about embedded systems and session 12 and as a part of embedded system programming, and in this session we are going to discuss about DC motors and PWM. Is how these two are linked. That give you a good idea about how to do the speed control of DC motors. Okay, that be very interesting thing. And the last session we discussed about the frequency and time relation. Okay, so I hope I would have got the perfect understanding of that. It means that if somebody tells you that if my thing is 20 kilohertz, it should say this 50 microseconds. If somebody say 50 hertz, you should say 20 milliseconds. If somebody said 40 mega, sorry, 200 megahertz, say 5 nanoseconds. See that how fast I'm doing. Simple. If it is kilo, normally it's milli, but don't put milli, you put micro, because you're going to put 1000 by 20. Then if it's 50 hertz, that means nothing. It's only nothing. So I'm adding milli, but I'm putting 1000 by 50. Now when I put here 200, 1000 by 200 is how much? 5. And mega means should be micro. Since I put 1000 here, I put nano. See how fast I'm doing that. This is a technique has to be followed. Let us say, if I say 25 kilohertz, then this 25 have to be converted to 1000 by 25 is 40. Then kilo will become milli, but you add 1000 here, so this becomes micro. That's it. How fast? 1 second. By seeing that, if you say anything about, let's say 500 kilohertz, how much? 1000 by 500 is 2. And kilo, since I put 1000, I have to convert this a mega, so microsecond. So 500 kilohertz means 2 microsecond. This is what all about period or T. The relation between period and the frequency. Now the trick here is, next one is, now you know that T and F. The next one is duty cycle. As I told you that duty is a one which is going to be performed. When this is 5 volt, duty is going to be performed. The total period is 1 second, or let us assume that 2 nanosecond, 2 microsecond. This gives you the frequency. If I say the period is 2 microsecond, then you know that, oh, the clock is 500 kilohertz. The other way also you should do that. If I say 2 microsecond, you should get to 500 megahertz. It's very simple. I'll tell you now how it is. If I say if I say T is equal to 2 microsecond, then F is equal to 1 by 2 microsecond. Micro only, forget about second, 2 micro. Because second become hertz. Now that is, understand, 1 by second is equal to hertz. That's it. 1 by hertz is equal to second. Because this is frequency, this is time. So I take only 2 micro. I put hertz here. F means hertz. Now 2 micro. So 1 by 2 into 10 power, how much? Minus 6. Am I right? 1 by 2 into 10 power minus 6 micro. When it goes up, 10 power 6, I make the 10 power 6 into 1 by 2 into 10 power 6. I make the 10 power 6 into 10 power 3 into 10 power 3. Am I right? Now this 10 power 3, I make it as 1000. So 1000 by 2 is equal to 500. 10 power 3 is kilohertz. That's it. Hertz is already there because of a second. Now you understand. If I say t is equal to 2 microsecond, then f is equal to 500 kilohertz. If I say that t is equal to 40, t is equal to 40 nanosecond, 40 nanosecond, then f is equal to 1 by, now we'll do it here. F is equal to 1 by 40 nanosecond is equal to 1 by 40 into 10 power minus 9, and second become hertz. So this is equal to 10 power minus 9. It becomes 10 power 9 when it goes up, divided by 40. It's equal to 1000 into 10 power 6, 10 power 3, putting 10 power 3. You split the 10 power 9 into 10 power 3 into 10 power 6 by 40. Now 10 power 3 means 1000. 10 power 6 is mega. Am I right? So is equal to 1000 by 20 is 25 megahertz. If you got the answer, then you are done. I have not seen it. I'm seeing a chat. Yeah, perfect. You understood. That's it. That's it, man. Now I think I'm both of you understood this calculation of T and F. If I give you T, you should be able to find F. If you find F, you should find the T. Now, still, if you have a confusion, let me know, please. I'll stop a minute. If you have a confusion, let me know. Otherwise, I'll proceed. Now, you will be thinking that why it is important. Why it is important. Okay, thanks. Keep it this live. You have to always remember this in everywhere. In the interview, everywhere, this will be very useful. You would be thinking they're very small, but these things will give you the very good thing in the interviews and in the GATE exam everywhere. You'll be very surprised. Now, next thing we expect was a duty cycle. Why duty cycle is, you know that motors or mechanical device. They are mechanical device. So they cannot, if you stop the motor, then it cannot stop so quick. It will take some time. Since if my time is in order of microseconds, then the motor cannot change the difference. But what is happening is, you supply 5 volt here, you supply 0 volt here. This is, let us assume that T on. This is total T. This is T off. So T is equal to T on plus T off. The total is a period. T on is a duty cycle. Now, if I ask you that what is the duty cycle of your waveform, if somebody says that it is 25%, then that means that T on divided by T is equal to 25% or 0.25. Now, if I tell you that the frequency is 100 hertz, 100 hertz. Now the duty cycle is, now I'll tell you, I'll find out that how do you tell me the answer. Now we know that there's a waveform. This is T1 or T on, sorry. This is T off. Now this time is T. Now I say that this guy frequency is 100 hertz and duty cycle is equal to 40%. Then what is T on is equal to how much? T off is equal to how much? Now I tell you that why I'm asking this. You'll be surprised. Why this calculation has to be done. Tell me that. What is T on? What is T off? I give you only these two information. F is equal to 100 hertz and duty cycle is equal to 40%. Then what is T on? What is T off? This is, if you know, you have to calculate this first before you start writing a software. If you don't know this, then you cannot write a software. Please. I want the answer. I'm waiting for your answer. I'm waiting for your answer. Please. Fine. I got one answer. Perfect. That's right. If you say how to count 40%, that's correct. Now it's a very clear. That's the way better. That's what I'm asking. You better learn it from me. So if you ask question, what is 40%? 40% means 40 by 100. That is what the meaning. See, understand always. Cent means 100. Century, everything is 100. When I say 40%, meaning 40%, that is 40 per 100. That means out of 100 items, I'm seeing 40 items. So 40% is equal to 40 by 100 equal to 0.4. Understand? So if I say 0.40%, then it is 0.4. Please understand. If I say 5%, means 5 by 100, it's equal to 0.05. If we say 2%, means 2 by 100 is equal to 0.02. That you have to be very clear on that. Now, if I say that duty cycle, what is duty cycle? I have a waveform. I have a clock. In that, I have a signal. Now, this time is called T. This is called T on. This is called T off. This is called T off. So T on, sorry, T is equal to T on plus T off. T on plus T off is T. So T on during only the T on time. That means that you are getting a 5 volt. Then the motor is going to rotate. Not this time. When you are giving 0, that motor is not going to rotate. No power, no current. Voltage is 0 means current is 0. But 5 volt means current is there. So duty cycle T on by T. Out of total time, he is going to perform the duty only this time. For example, in the office, you have 28 hours. You work only for 2 hours. Then your duty cycle is 25%. If you work for 4 hours, then 4 by 8 is 0.5 is equal to 50%. If you say that, oh, that guy, his productivity is 100%, man, that means that you work all the 8 hours. If you say that that guy's productivity is only that 50%, then you will work 0.5. That is your working time by 8 hours. So 8 into 0.5 is equal to 4 hours. Now let us come to this question. So now duty cycle is T on by T. I said now is equal to 40%. Is equal to 0.4. So T on is equal to 0.4 into T. Now you have to find T. How do you find T? So please understand, if I say duty cycle, if I say that 20% duty cycle is equal to 20%, then T on by T is equal to 20% is equal to 0.2. So T on is equal to 0.2 into T. That is what the calculation. Now you have to find T. I said 100 kilohertz. Sorry, 100 hertz. 100 hertz is equal to 1 by 100, which we already did. And the hertz becomes second. Now 1 by 100, I multiply by 10 power 3 by 10 power 3. This 10 power 3 becomes 1000. This 10 power 3 becomes 10 power minus 3. So 1000 by 100 is 10. 10 power minus 3 is milli. And S is second. It becomes 10 millisecond. It becomes 10 millisecond. 10, correct, 10 millisecond. So we calculate now T is equal to 10 millisecond if F is equal to 100 hertz. Now T on is equal to 0.2 into T. How much? 10 milliseconds. So 10 into 0.2 is 2 milliseconds. So T on is 2 milliseconds. And T off is 8 milliseconds. Because total time is 10 milliseconds. Am I right now? Now you calculate the time what you wanted. That is what the trick. That is what you have to calculate if you have to do the PWM. That we'll discuss what is PWM. Okay, next. You don't know what we discuss is a PWM. What we discuss is a PWM. That is, we are changing the pulse width by which we are controlling the voltage. That's why we call it as we are modulating the voltage to pulse width. That's why we call this as a pulse width modulation. Pulse. If I say that, let us assume that. I give you another thing now. Let us see how you are understanding. I want to make sure that you are understanding. I want, my supply is 12 volts. My supply is 12 volts. See, supply voltage. I want, if I give the motor, I have a motor. If I give 1.2 volts, then the motor will run at 50 RPM. For various speeds, the motor speed will vary. You know that RPM is rotation per minute. Now, if I give 1.2 volt, I'll give you a table now. I give a table. Okay, let me block this video. If we give here 1.2 volts, 50 RPM, 50. If you give 3.6 volt, then it's going to give you 200 RPM. This is a voltage. This is voltage. This is RPM. If you give 7.2 volts, it's going to give you 500 RPM. If you give 12 volts, then it is going to give 2000 RPM. I've given you the table. Now, I am telling you that I am supplying a frequency of 200 kilohertz. How much? 200 kilohertz. I want the motor to rotate at 500 RPM. I want the motor to rotate at 500 RPM. What should be the, this is what you're controlling through microcontroller. Okay. The output on time is 12 volts because that is what supply voltage is, 12 volts. You're going to on the switch frequency. Now I'm asking you, what is T on? That's the question is, what is T on? From this information, can you tell me? I've given you all the information. Can you tell me what is T on? I want the motor to rotate at 50 RPM. That's speed. So in that case, I'm using a clock of 200 kilohertz. Now tell me, what is the T on time? Anybody? Please. If you're confused, let me know that where you are getting confused. If you're confused, let me know where you are getting confused. Why you are not able to solve it. There are about few steps. I want to know that which step you are confusing, where you don't understand. Then we can solve it. Please let me know that where you get confused. That we have to be very clear. If you're confused, if you're not confused, you should solve the problem now. Otherwise, let me know that which step you're confused. I have given a table. I have given a table. What voltage, what speed. This motor manufacturer, I told you that each voltage, what speed. My supply voltage is 12 volts. Now tell me that what is the T on time? Please. No, I don't know what method you use, same method. I'm giving you the information. I want the T on time. That's it. You can use any method. I want the T on time. What I have done is I did not give you duty cycle. Now you have to calculate the duty cycle. How do you find a duty cycle? You see here, this I given a 1.2 volts, 50 RPM. So 50 RPM means I should give 1.2 volts. That means T on by T is equal to 0.1 because you're applying 12 volts. So 1.2 volts divided by 12 volt is equal to 0.1 or 10%. Duty cycle is 10%. That means T on by T is equal to 0.1. You calculate now. Now this is done. So T on is equal to 0.1 into T. That we have calculated. Now this 0.1 is a 1. We got it. We got this 0.1 here. Now, how do you find T? I given 200 kilohertz. So 1 by 200 kilohertz is equal to 1 by 200 into 1 by 10 power minus 3. Because, sorry, 10 power 3. Because kilo is 10 power 3. And 1 by hertz is second. So the 1 by 10 power 3 becomes 10 power minus 3. Okay. But I have a 200 here. So what I have done here is, sorry, into 1 power 10 power 3. Now I do here, multiply by 1000 by 1000. So this becomes 10 power 3. So 1000 by 2 is 5. 10 power 3 becomes 10 power minus 6. So T is equal to 5 microsecond. If you have not understood it, you have to do it. You have to do it tonight homework. Make sure that you understand this. 5 microsecond. Please try to understand this. 5 microsecond. So T on is equal to 0.1 into T. So is equal to T on 0.1 into 5 microseconds is equal to 0.5 microseconds. That is what the T on time. So see the steps. See the steps. I remove this everything. I start writing the steps. I gave you only one. I gave you the table. Then I say that I need 50 RPM. I need 50 RPM, which I gave you the information. When I say 50 RPM, from the table, you should arrive 1.2 volts. I also said that supply voltage is 12 volt. But you want 1.2 volt. So 1.2 divided by 12 volts is equal to 0.1 volt. Is equal to 10% of duty cycle. Now, if it is a 10% duty cycle or 0.1, so it's 0.1. Now we calculate. Now we know that T on by T, the clock, T on by T equal to duty cycle. This is equal to 0.1. Therefore, T on is equal to 0.1 into T. Done. We have calculated. Now I have to find the T. I told you the frequency is 200 kilohertz. So T is equal to 1 by F is equal to 1 by 200 kilohertz. It's equal to 5 microseconds. This you should calculate. This you should calculate, practice at home. So T on is equal to 0.1 into 5 microseconds is equal to 0.5 microseconds. Done. If you are thorough with this calculation, then only you can start writing a software. If you don't know these calculations, but understand one thing, I have used simple addition, multiplication, division only. I have not done anything big. If you say that this is a confusion, then you have to practice at your home today. Yeah, T on is equal to 2 microsecond. T on is equal to, how come you got 2 microsecond? It is 0.5 microseconds. Do the calculation. I've done a full calculation. Watch it. It's 0.5 microsecond, not 2 microseconds. That's a trick. I know that. I know you will have a small confusions. Yeah, T on by T is equal to duty cycle. T on is equal to duty cycle into T. Am I right? That's why I've written T on is equal to duty cycle into T. That is 0.1 into T. So T is 5 microsecond. Then 0.1 into 5 is 0.5 microsecond. Perfect. You are right. T on by T is equal to duty cycle. You are right. Perfectly right. That's why I've written here. If you see here, I've written here. Duty cycle is equal to T on by T is equal to 0.1. So T on is equal to 0.1 into T, which I've told you. Exactly. Is it clear? If, I'm not really worried about whether it's clear or not. This video is, fortunately I'm recording, I think. So let me check. I'm recording. Okay, I will upload it today. I will upload it tonight. And please make sure that you understand this. If you don't understand this, you have to be very clear about this. Not to have a 0.1% doubt. If you give any duty cycle, anything you should be able to find out. Then I'll explain to you tomorrow. Tomorrow I'll explain to you that how to write a software for this. That's a trick. You calculate this, then we calculate how to write a software for this. I know that. I don't want to do today a software part because then you'll have a lot of confusion. I want you to understand this first. I want you to understand this full calculation very thoroughly. That means that if I give you any voltage, any speed, that's what they will give you. They will tell you that at what speed, what voltage. That is the only information you will get. From that, you should be able to write a software to control this. Yeah, it's actually changing the duty cycle of the square wave. That's all. Duty cycle of the square wave. It's called pulse width modulation. And it is used to control the motor speed. That's it. It will give you the average voltage change. That is, actually, I'm changing the pulse width based on the required voltage. You are changing the pulse width based on the required voltage, average voltage. That's called pulse width modulation. That's actually a definition. Okay. You are changing the average voltage. That is what the actually purpose. That means that if we change the voltage, then the motor speed will change. Now, by changing the pulse width, we are changing the voltage. That's a very beautiful concept. And this is what used in your all your application, whether it's a robotics, everywhere, only PWM. All your control systems, everywhere is PWM. We will do that. I told you, it's not start. This is only a start. Tomorrow class, I'll explain to you more on that. And make sure that you understand this thoroughly. Okay, let me stop the recording and